All right, yesterday we talked about how to solve quadratic equations in standard form with the graphing method. So this is our standard form here, x squared plus bx plus c. So it might be something like 1x squared plus 3x plus 2. We made sure it equaled 0. We could graph that darn thing. We'd find out, I think in this case, it'd cross at -1, -2, something like that. Vertex somewhere down here. But we were looking for those zeros. Okay? Because those are the x values that make this equation true. Okay, now we also talked about the fact that, hey, we're going to do that with Desmos because you don't know quadratics as well as I do, so you'd use Desmos, we could graph the darn thing. We could find the solutions just by touching these points, and we'd find out -2 there and -1 for the other. We're going to look at some other methods, though, today to solve quadratic equations, and not other methods. I should use the singular because we're going to focus on what is called the square root method. Now, the square root method only works, and I cannot emphasize this enough, only works when there is no middle term. No linear term. That's the x to the first power term. It's called our linear term. So let's look at an example of a problem like that. And we'll make it quadratic, so x squared. And let's just do equals 16. Now, clearly, if I was just to look at this problem, I'd go, okay, x could be 4, because 4 squared is 16. That makes it true, and you'd be absolutely correct. But there is another answer that makes it true as well, and that is -4. When I take a -4 and square it, -4 times -4 is also 16. So this has two answers, like we would expect from a quadratic equation. And the method we use is we want to isolate this x squared term, make sure the x squared is all alone, and then we just have to square root both sides, the opposite of squaring. But whenever you square root both sides, you always get plus or minus. We get the positive and the negative of whatever the square root of 16 is, and in this case it's just 4. So there's our two solutions. So if we were to graph this guy, you would certainly see he crosses at 1, 2, 3, 4, and 1, 2, 3, -4. He'd cross like that, and looks something like that. He'd actually cross down here, I think, at -2, but it's those zeros that we're looking for again. But the key thing is, get the x squared by itself, square root both sides, plus or minus, and you have your answers. I wish it was all that easy, and it is not, but it's all right. Let's look at another one, x squared minus 121 equals 0. So some of the identifiers you want to look for. First of all, you have an x to the second power. That makes it quadratic. That's your highest exponent. There's no x term. There's no linear term. So this is just like your ax squared plus bx plus c equals 0, but there's no b term. We do have a constant term. Isolate the x squared, which means get the x squared alone. In this case, we just add 121 to both sides. Once x squared's alone, we just square root both sides. X equals, we go plus or minus, square root of 121 is 11. You can check that on your calculator. But that means the zeros where it crosses the x-axis are at 11 and -11. Let's get a little more complicated. Let's go with 2x squared minus 72 equals 0. Again, we identified it's quadratic, x squared. There's no x term, so we can use the square root method. Let's get that x squared alone. So we'll go add 72 to both sides and do that subtraction first. 2x squared equals 72. Now the x squared's not quite alone yet. It's got that 2 in front of it, so let's divide by 2. Undo that multiplication. X squared equals 36. And we'll square root both sides. Once x squared's alone, plus or minus square root of 36 is 6. So we got plus or minus 6 are the two answers. Again, the zeros, this is where this parabola would cross. 6 and negative 6. That parabola would look something like that, but of course that's just a sketch. So all we're looking for is those zeros again. Where does it cross the x-axis? And we do that by using the square root method. A little more complicated. Let's use 9x squared minus, don't want to use that. Trying to do something similar to your homework, but a little bit different. Choose 25, there we go. Equals 0. Let's get that x squared alone. Again, it's quadratic because of the x squared. There's no linear term, no x term. 9x squared equals 25. Let's divide by 9. Now you could go to decimal here. I'd encourage you not to, though. Leave it as a fraction. Now we just have to square root both sides, and we have to square root a fraction here, which for many is going to be uncomfortable, but don't worry about it. It's plus or minus. Square root the numerator, 5. Square root the denominator, 3. So plus or minus 5/3, or 1 2/3 plus or minus. Let's try one more of these before we get into something a little bit more complicated. Let's try this guy. X squared minus 45 equals 0. Looks very simple. I've got a quadratic. I have no linear term. So I'll take the 45 to the other side and square root both sides. X squared equals 45. Here comes the square root. However, this is where I run into a problem. I cannot square root 45. It's not a perfect square. Think about perfect squares. 1 squared is 1, 2 squared is 4. These are all our perfect squares, things we want to have in our brain. I'm going to get past 45 here. There we go. 7 squared is 49. So we can't take the perfect square root of this. So this is where we have to go back to what we learned in geometry, which is we have to simplify it by factoring it. Now 45 factors a few ways. 45 is 1 times 45. It's also 3 times 15. It's also 5 times 9. And I'm going to use the 5 by 9 factorization. So 5 times 9 is 45, and the reason I want to use it is because 9, you can see over here, is a perfect square, which means I can square root the 9 part. Square root of 9 is 3, and I'll leave the 5 underneath the radical. Even if we were to graph this problem, we'd get these really ugly decimals because root 5 is irrational, this decimal that never ends. So we just have to leave it as a positive or negative. So x is plus or minus 3 times the square root of 5, this crazy decimal. Let's try another one. There we go. A little more complicated. we can see it's just quadratic with no x term in it. Let's just kind of walk through how we do this. Subtract that 14, starting to get the x squared by itself. 2/3 x squared equals 6. X squared's almost alone, but it's got that darn 2/3 in front of it. So I'm going to undo that by multiplying by the reciprocal, 3/2. Just undoing it using order of operations, because 3 times 2 on top is 6. 2 times 3 is 6, and 6 over 6 is 1. So that's just x squared at that point. You can also think of it as 3 over 3 is 1, and 2 over 2 is 1. On the right-hand side now, think of this as 6 over 1, so I can multiply the fractions. 18 over 2. So x squared equals 9. And now you can square root both sides. X equals plus or minus 3. Two different answers. Again, I know if I graph this, it would cross the x-axis at plus 3 and minus 3. This one's a little bit on the nasty side. X squared, no linear term, so let's get that term. So let's get that x squared alone. I'll subtract 1 here. I'll divide by -2. And I get 7/2, negative over negative. But again, when I square root both sides, I cannot take the square root of a 7. And I cannot take the square root of a 2. And so this answer right here, this root 7 over 2, is kind of acceptable. Okay, but one of the things we worked on in geometry is you can never have a square root of a number in the denominator down here. So how do we get rid of that? Well, when you have a root of a fraction, you can separate it like so. That's the same thing. And now we fix it. It's called rationalizing denominators. And if we're dealing with square roots, all you have to do is take it times itself. Let me show you what happens here. We get plus or minus 7 times 2, that's just root 14. Here comes the rationalization part. Root 2 times root 2 is a root 4. And the square root of 4 is just a 2. And so now my denominator is no longer a square root number, an irrational number. So that's this beautiful just 2. And so my answers would be plus root 14 over 2 and minus root 14 over 2. Your homework today, I tried to eliminate most of these and practice just in solving with the square root method. I'm going to clean this one up just a little bit. I think we need a nicer problem. Let's look at this guy. Now notice this one's a little bit different than every other single problem we've looked at. The x is trapped inside parentheses. But it's inside parentheses that have a square on it. Notice the squared part, just like we got x squared alone, this term with the x in it is by itself. It's isolated on the left-hand side. And as long as that's the case, we can just square root the left and square root the right. The square root undoes the squaring. The square root of 25 is plus or minus 5. Now, I haven't solved it yet because it's x minus 6 is plus or minus 5. So, key step here, I'm going to add that 6 to both sides and move it over. And I get x equals 6 plus or minus 5. Now, this is two different kind of equations. This is 6 plus 5. It's also the 6 minus 5. So I first did the 6 plus 5 to get an answer, 11. And then the 6 minus 5 to get an answer, 1. So there's two answers to this quadratic equation we have up here. X could be 11, or X could be a 1, and both would give us an equality and check to be true. All right, that gives you a preview. It's a tough little assignment. We'll work on this tomorrow and probably on Wednesday as well.